Today we will create a targeting system the likes that you know of most strategy games. The player can choose which enemy his tower or units shall attack, and that can be between closest to weakest, maybe just a random enemy, and maybe the ones that are the furthest away. To make things simpler, we will set it up inside of a more simple scene, and you might recognize this a little bit from the scene that we set up the last time in our spawner video. Now we left things last time here, where we endlessly spawn enemies from the right side of the screen and they walk endlessly to the left side of the screen. First, we will implement a target system, and we will go about it in a few steps. First, we create the tower so that we can save all the enemies in an array, and then we create a projectile so that we can shoot the enemy and attack the first enemy in this array. And then we will set up the logic for our targeting modes. And lastly, we will then create the drop down button so that we can choose the attack mode for each unit inside of our scene. First, what we do is create the tower. And for that, I choose an area 2D and we give it a collision shape as usually. Then we will give it a sprite 2D as well in order to give it a texture. Now let's save all this branch as a scene. Put it inside the scenes folder, call it tower and hit save. Now let's open the scene and I will rename the area 2D to tower as well to be consistent. The shape, I will choose, well, let's go with the rectangle shape, and it would probably be about this big. Let's add our sprite to the sprite 2D, and I see I hit the size perfectly. Now let's make it more crisp by going to the textures, and in the filter we select nearest, save the scene and go to the main scene. The tower is a bit small compared to the units that were spawned, so I think I'll make the tower a little bit bigger. And I just notice we have a problem with the collision shape as well. It should not be the shape of the tower, but instead this is our range in which we check if enemies are close by to be attacked. So I want this to be rather large. Let's make this bigger and still a little bit more perhaps. And we save this again. Now everything that enters this area should be saved inside of an array that we have in each tower. So let's create a script so that we can create this array. Let's go to our scripts and create tower.gd. And inside of our script, we already create the function ready because I know that we will need it. But before we set up anything else, let's go with the enemy array first. So let's call a new variable, and I call this enemy R. Let's make it capitalized. And this will be an array that saves. It will save packed scenes, I believe. Now what's left is to go onto our area and connect the signals body entered and body exited so that we can check on the enemies that go in and out of this area. In here, the logic is quite simple. All I want to do is to check if I already have this enemy inside of my array. And if I don't have the body inside, what I want to do is then simply add the body to this array. So we call enemy array dot append, and then we add the body. And for our body exited case, we do the reverse thing. We call enemy array. We don't negate the has body because we hope it has the body. If it does not have the body, we don't want to erase anything, and we use the erase body function to get it out of our array. Now through this, we should already be able to get some enemies inside of our array by everyone who enters this area, it will be added to this enemy array. So we could print the enemies, or actually rather the size of our array, to know how many enemies are inside of it. So let's try this out real quick. And down in the console, we see we have 0 enemies, we have 0 enemies, we still have 0 enemies, and still 0. So something's not right here. Let me see. I believe it's not packed scenes then. Obviously, what we have are character bodies that enter our area that we want to add to our array. Let's try this again. And now, yes, we have 1 enemy, 2 enemies, 3 enemies inside of our array, and etc. And it goes on. Let's see. We have 6, 7. It should stop at some point. Yes. Yes, so we have all the time 7 enemies inside of our area. To visualize it a little bit better, let's go to debug and show our collision shape. And we can see that we have at all times 7 enemies inside of this area. Just when the 7th is leaving, a new one is popping in. So that works. Now let's move on to the next step. Let's erase this print function again. And the next thing we will set up is the attack function and the target selection. So first we will need a timer, and I call this one an attack timer. And we are going to connect the signal of this attack timer later. And in our ready function, we will give this attack timer some values. The wait time, for example, we are going to give it the attack speed that our tower has. It is highly possible that each tower has different attack speeds. So let's give it a variable that we call attack speed, and we set it to, no wait, let's make it a float. And we set it to, I don't know, 2 seconds. Then we will set the auto start so that it repeats itself to true. So auto start true. And lastly, we will just start the attack timer. Now all that's left is connect the attack timer signal, the timeout function, to our script. On here, every 2 seconds now something is going to be called. And something that I want to happen in this function here, that will be to select a target, and we want to, well, spawn a projectile, like shoot the target. Now let's go with the select target first, because that's quite simple. First we create a target, and we will call a function which is called getTarget. Let's put that down here real quick, getTarget, and for now we pass on it. And then to spawn a projectile, we will also call a function if we have a target. If the target is null, we don't want to call or shoot anything. So if we have a target, we will shoot the target. Let's create the shoot function down here as well, real quick. Target, and we pass on this too. Now, the easiest way to get a target is, since we have an array with enemies, let me delete that quickly. Since we have an array with enemies, what I can do is just select the first enemy that I have in this array. And so simply, I just have my first target that I can shoot at. We will refine this logic later when we give it more complex target selections. For the shooting, I have to create a new scene first, because we need a projectile that we can shoot. For the projectile, I also choose to have an area 2D, and I rename this to projectile. Here as well, let's give it a collision shape, and obviously a sprite 2D as well, so that we can see it. The collision shape, let's go into the scene. Well, let's give it a sprite first. Let's go into the scene and scroll in a little bit. Let's make here a texture and put it to nearest. And then the collision shape, let's do a round shape and try to adjust it to our projectile. Cool. We save the scene and we put it inside of our script of our scene folder, and then we add a script to our projectile. Let's save that inside of our script folder. And in here, we will first declare a few variables. Obviously, our speed variable to define how quickly our bullet is going to fly. Let's put that to 300. And I need a target where I can fly towards to. So let's put the target as a type of node 2D that we want to go to. And then also I want to have a default value for the damage that is going to be a damage of 5. Great. We're not going to do much here with the projectile. We just need the projectile to fly towards the enemy. And when it hits the enemy, we want it to perish. So first let's make the movement. If we have a target and the target is instantiated, that is important, because if we don't have a target, wait, let me just do this real quick. Target, because if we don't have a target and we try to fly towards a target that despawned, we have a problem. Our game crashes. Good. We take the direction. There's a typo. We take the direction, and that is going to be first the target position, or actually the global position, minus our own position. This is the position of the projectile. And then we will normalize all of this, because we want the values between 0 and 1 for the x and y axis, so that we can multiply it by our speed without going to lightning speed. So position is just going to be an addition of its own position times direction times speed multiplied by delta. The else case, if we don't have a target, we want to queue free. That means we are not going anywhere, we just despawn the bullet. There are smarter ways to solve this, but for now, let's go with it. Let's also get the body entered signal connected to our script. And what we do when we enter this body is, since we have the information what we collided with, we want to check if the body that we collide with is actually our target. And if it is our target, we want to see if it has the function to take damage. And we pass in the damage that we have defined earlier up here. And I believe that's it. No, we still have to queue free our bullet once we hit the target, so that it is not longer on the screen. And now I think our projectile is already done. We can go to the tower, and if we want to shoot the projectile, first our tower has to know of the projectile. So let's go to the top and let's make an export variable, which I call projectile because I'm not creative. And that is of type packed scene. Since we made an export variable out of it, now we can go to the inspector of our tower and we can load our scene that we've just created. Let's pick the projectile and open. Cool, we know of the projectile. So all we have to do now is instantiate it. So let's create a new variable and call it new projectile. And that is projectile.instantiate. And then we can do whatever with our projectile. So I think we have to set the damage of the projectile, and let's set that to the tower damage, because also each tower could have different damages. So let's say attack damage, and let's default it to 5. It's not going to change anything because it has default 5 anyway, but if we would change the damage on a tower later, that would be respected here. So let's put that to attack damage, and What else do we need? The position of the projectile should be the position of our tower as well. And for it to exist in this world, we need to add the child to, well, let's use the parent node, because if for some reason my tower disappears, then I have a problem. So let's say new projectile is added to our world scene. Great. With this, can we already try hitting some enemies? No, because I remember now we have no damage function in our enemies. So let's do that real quick. We forgot that and we made the enemy spawner, but it's not going to take much longer. We say take damage and we get an amount of damage that we receive from our fire bullet. Then we say health is minus the amount. And if we have 0 health, yeah, we put it here. If we have 0 health, then we will queue free our enemy. So let's do that real quick. Actually, 0 or less than 0. And then we queue free. Good. I think we can start now, but since we already have a health bar, let me just quickly update the health bar whenever we take some damage. So we put that in here. Once we take some damage, we will call the health bar and we will call the value on the health bar, and that will be equal to the health that we have remaining. Now let's start and see what happens. Ooh, we instantly crash. Why do we crash? Obviously because in our when we choose the enemy and the enemy array is empty, we have a problem. So we have to check if the enemy array is empty. If it is, we should do nothing. If it's not empty, then we can select the very first enemy in line. And still nothing happens. Let me really quickly check why that could be. We get a target, we shoot a target, but we never tell our bullet what the target is, so it instantly queues free. We obviously have to tell it that his target is the target that we got from the getTarget function. Now, fingers crossed, everything should work now. And yes, it does. Fabulous. Good. But let's establish a more solidifying logic for getting the target. This is all fine, but let's reverse the case. If the array is empty, we return null. That means we don't have a target on the projectile, and the projectile despawns instantly, and we don't run into issues or crashes. Then, if we have a target, what we're going to do is we use a match statement, and I want to match different target modes. Yeah, let's put that up here real quick. Variable my target mode is going to be a string, and I think we default it to the closest enemy. Now let's establish the logic to find the closest enemy. We make a match for target mode, and if we have in target mode the closest enemy as a string, there was a mistake, now it works. If we have target mode the closest enemy, what we are going to do is we return and whatever the closest enemy is. Okay, let's comment that out real quick and copy paste this. Not all that. And we will have a multitude of cases that we are going to match here. So the first one is closest, the second is the farthest enemy. Then I want the weakest enemy and an option for the strongest enemy, and then a random enemy. You can make as many cases as you want, For me, for this setup, this will be enough. Let's start with the closest enemy. And for that, we will return whatever we get from a function call that we now create. Closest enemy is going to be a function that I define down here, and it's going to return the enemy that is the closest to the tower. And it's much easier than you might expect. Let's start first by writing or defining the variable that we want to return later. That is going to be closest enemy. And that's what we will return, closest enemy. Now let's check that, again, the case, our array should not be empty. So enemy array should not, and dot is empty. And if it's not, then my closest enemy that I'm going to start with is by default the enemy that's at the beginning of the array. So I take my enemy array and the index 0. And now I will check every enemy in this array to see if there's any enemy that's closer than this one. So for I in enemy array, I want to check if the closest, no, actually, I want to check if the I.position.distance to, so we're going to check the distance between the enemy in the position I of the array to our tower. The position here, that's the tower position. If that is smaller than the closest enemy position to our tower, distance to, I'm very prone to typos, so I have to concentrate here. Position, great. Then our closest enemy is going to be, you guessed it, I. And we keep repeating this process for all the enemies in the array. And then we have the closest enemies that we can send back to our switch statement. This is all we need, or almost all we need, to do all the other cases as well. So bear with me. I will really quickly establish the farthest enemy. Let's Shift, Alt, and click wherever we need to change the text. Erase this real quick and call this farthest. And then we reverse the check. The position should be now greater than, not smaller than the previous one. So this one we reverse. Okay. And that's already it for the farthest enemy. Easier than you thought, right? Let's put that in our match statement up here. Farthest enemy, here we go. And let's keep rolling. Let's do the weakest and the strongest as well. They're going to be pretty much all the same process. So I create the function, which is called weakest enemy. I replace all the farthest. I don't know if that's even the real word for it. I just made it up, I suppose. Let's put weakest enemy. And here we are not checking. Well, we do check the same thing if we don't have an enemy, and we do still do the same. We start with the enemy at the index position 0, but we check for the health and not for the position. And here let's reverse, because we look for the weakest enemy. So if the health is smaller than the weakest enemy.health, then the new weakest enemy is going to be I. And we can copy paste all this and make the same process for the strongest enemy. So this part here of the video is really straightforward, and I hope it makes sense to everyone. I'm going to try to rush through it a little bit. Let's put strongest, and here we reverse. If health is greater than the strongest enemy's health, then it's the new strongest enemy. Cool. Let's put them in our match case, and then we just have one to do. So let's do weakest. Here goes strongest. And all we have to do now is to get a random enemy. And this one is the easiest of them all. We have an array. So let's do func random enemy. Let's create that real quick. And since we already have an array, we just have to check if it's empty. So we do basically what's up here. But we will not have to test anything else. We know there's an enemy in there or multiple. We can just return a random enemy from this array. So let's write enemy array dot pick random it is. Pick random, and we already have a random enemy that's inside of our array. Fun. I think we have everything that we need to spawn a projectile, have a target, and we can already go and test with our default closest target. We can run the game and see if this logic works for the time being. So he attacks the closest enemy, which is right now this one in the array, still this one. Now he should switch. Yeah, he switches. Great. He switched it to the next, and to the next, and to the next. And we always attack the closest target. Now let's try to attack the strongest. Strongest means the one with the most HP. So whenever an enemy is damaged, he should not count as the strongest anymore, and he should switch to the next target. And indeed, he does. He always tries to attack the one with the most HP. We could make this a little bit more fun if we take one of the enemies, so the case if it's smaller or equal to 3, and we divide the health by 2 so that it has less health, to see if the switch really happens. And yeah, let's update the health bar as well. The max value, actually not the value, and the value as well. Health bar.value is going to be the same as health. Let's instantiate a few more towers. I deleted the one that I had put in earlier and added it freshly, just to prevent any bugs from happening. And let's see, let's put the collision shapes off, and let's see if we can test our attack logic with seeking the strongest enemy with the most HP. So the blue ones should have the most HP, the red ones the least. So they should always switch to the blue ones, except for the red ones have more HP than a blue one. They ignore the red one, that is a very good sign, and they always try to attack the blue ones with the most HP. We could go now and do all the cases here, like the random function, it also works well, but let's do something more interesting. What we want to do is establish a logic where we can select the target mode inside of our game. For this, what I'm going to do is I create an array with all the target modes that I want to have. So let's make the array target modes. And this is going to be of type strings only. And in here, I will write all the target modes that I want to have. Let's put closest. Let's copy paste this real quick. And put them in the right order that you want it to have in your drop down button. This is important. So the order that you write here has later to be the same as in the button that we're going to create now. And we can access them by the index of the button. You will see what I mean in a second. So first, let's create this button. We use the option button down here. Click on create. Click on the button and then go into the inspector. You see that there's an items drop down, and there you can add elements. If you add an element, give it the name of the name that you want to choose on the button, on the drop down, and make it the same order as your string array. This is an important step because, well, I'll explain it later. Let me just fill this up real quick. Fast, weakest, strongest, and random. Great. So you can see they all have an index. Like this is index, whoops. This is index 4 and ID 4. This is ID 3, ID 2, ID 1, and ID 0. They perfectly match to the indexes that we have here inside of our array. So we can use these to map to our strings. Now we go to Node and of the option button, and we use item selected and attach this signal to our tower as well. Every time we select a new item, we get an index, so a number that we have here. Remember, that's the ID. And the handy thing is we can now go in here and simply say our target mode is going to be whatever target mode is at the target mode's index that we select. And like this, we can select all the target modes inside of our tower. Let's go into the scene real quick and arrange the button so that it's aligned neatly. Doesn't have to move much. And then let's try it out. You can click on the drop down and you can see that you can select now different types of targeting. So let's do the weakest here, and maybe here we just attack some randoms. So the ones at the beginning, they always attack the closest enemy, while the ones in the middle, they try to attack the weakest enemies. And at the back, they just attack randomly. Now there's one thing that I almost forgot that's going to break your game. What if an enemy dies from the tower damage? You see, we don't respect this case in our adding and erasing bodies from our array. And it could be that the random function would choose an enemy that is not there any longer and your game crashes. Let's prevent that case from happening. Let's go down here in your scenes folder, and we will create a new script. This script, we save it in our scripts folder. And I will call this signals, because this script is only there to store all my signals that I want to have connected to any node in my scenes. Let's right click on the signals that we just created, and you go to copy path. Then we go to the project and the project settings. And in your project settings, look for the globals tab and paste in the directory of the signals that we just created. Make sure we add it and that this one is enabled. And then we can close this window again. What we just created is a global script. In here we can define a signal now, and I call this enemy died. The reason I'm doing it like this is to have a bridge between my enemy and my tower scene. I can now go inside of this enemy scene, and when his health drops below 0 or is 0, I want to call the signal that I have in my signals script. And he already knows that there is one that is called enemy died, and I emit the signal. Along with it, I pass the body, or actually the enemy that has died. This is important because now I can go into my ready function here and connect to the same signal. I will call signals, and dot. Here he knows of enemy died as well because it's a global script. I can connect to it easily, and I will give it the function where I want to, let's call it erase cleanup, the function that I want to call when I receive the signal. Let's create this last function real quick. It's called erase cleanup, and it receives a body, an enemy, so to say. And now we can also check in our array for each tower, do I have this enemy? And if I have this enemy, I want it to be erased. So does my enemy array has enemy? And if yes, I want to erase the enemy from the array. Great. If not, we just don't do anything. The cool thing is every tower now receives this signal and can remove this enemy independently if they receive the signal from the dying enemy. If they never had the enemy, no problem. If they had the enemy, it's gone now, and our game will not crash. I know it was a long video, but if you liked it, please give it a thumbs up so that others can find this video as well. In the next video, we will have a look at how you can make objects interactable by clicking on them like these little guys here. Keep creating awesome games, and see you in the next one.